Today we will study properties of rotation matrices. Observe. Definition 3.1. The special orthogonal group SO3, also known as the group of rotation matrices, is the set of all 3 cross 3 real matrices R that satisfy these two property: transpose of R into R, identity matrix, and 2, determinant R is 1 for anti-clockwise for right-handed frame. Definition 3.2. The special orthogonal group SO2 is the set of all 2 cross 2 real matrices R that satisfies 1, transpose of R into R equal to identity matrix, and determinant R equal to 1. From the definition, it follows that every rotation matrix belongs to SO2 can be written in the form of R11, R12, R21, R22, that is cos theta minus sin theta cos theta. For anti-clockwise rotation, theta positive, and for clockwise rotation, theta is negative, where theta belongs to close open interval 0 to pi. The elements of SO2 represents planar orientations and the elements of SO3 represent spatial orientation. Do you know the degree of freedom of planar rigid body in 2D R3 for 1.2 coordinates x, y, and for orientation angle theta? So for orientation point of view, planar rigid body in 2D has 1 degree of freedom. Now we will discuss interesting topic about this. Suppose today we will discuss interesting topic. Suppose in 2D rotation matrix there are 4 entries A, B, C, D. So transpose of R, row connected column, so A, C, B, D. We require, there are 4 entries, so we can select only one independently. After that, the rest 3 elements comes through maths. So degree of freedom for rotation, orientation point of view is 1. We will visualize this. We require determinant R is 1, and so what is determinant? AD minus BC. So we require AD minus BC is 1. This is equation number 0. And transpose of R into R, we require identity matrix. So if we multiply these two, we get A square plus C square, AB plus CD, AB plus CD, B square plus D square, which is equal to identity matrix 1, 0, 0, 1. So this one is 1, this one is 0, this one is 1. So there are another 3 equation, and these two, this one is 0. So A square plus C square is 1, B square plus D square is 1. Moreover, AB plus CD we require 0. So there are 4 equations, 4. AD minus BC is 1, A square plus C square is 1, B square plus D square is 1, and AB plus CD is 0. Suppose, and this is rotation matrix, so all element cos theta minus sin theta cos theta must be in the range closed interval minus 1 to 1, but we can select only one of them independently. The rest 3 we get through maths. See here, suppose we take A equal to half, so A square plus C square is 1. So if we put this 1 by 4 plus C square is 1, so C square is 3 by 4. So C is plus or minus root 3 by 2. There are 2 values for C. We will take turn by turn. Initially we are selecting plus root 3 by 2. So from AB plus CD is 0. If we put A is half and C is root 3 by 2, we get half B plus root 3 by 2D equal to 0. And this one, AD minus BC is 1, but A is half, and if we put C is plus root 3 by 2, we get half D minus root 3 by 2B equal to 1. Multiplying both the sides by 2, we get D minus root 3B equal to 2. This one, D minus root 3B equal to 2, and multiplying this by 2, we get B plus root 3D equal to 0. Now we will solve these two equations. Multiplying this by root 3, we get root 3B plus 3D equal to 0. Now adding these two, this one cut out, so D plus 3D is 4D, this is 2, so D is half. And so if we put D is half, this in this equation, we get B is minus root 3 by 2. So we have A equal to half, B equal to minus root 3 by 2, C equal to root 3 by 2, and D is half for theta equal to 60. Cos theta minus sin theta, sin theta, cos theta. Check it, which satisfies the AD minus BC is also 1 and determinant R equal to 1. Now, if we take C equal to minus root 3 by 2, C equal to minus root 3 by 2, this one, in this equation, A is half and C is minus root 3 by 2. So, half B minus root 3 by 2D equal to 0. Multiplying by 2, we get B minus root 3D equal to 0. From AD minus BC equal to 1, if we put A equal to half and C equal to minus root 3 by 2, we get half D plus root 3 by 2B equal to 1. Therefore, multiplying this by 2, D plus root 3B is 2. And this multiplying this equation by root 3, we get root 3B minus 3D equal to 0. Subtracting this cut out, and D plus 3D is 4D, it is 2, so D is half. And so if we put D half here in this equation, we get B is root 3 by 2. So A is half, B is root 3 by 2, C is minus root 3 by 2, and D is half. So taking A equal to only one number, we have two pairs, quadrupairs, this one and this one. Why? This one, suppose this coin, this is Abraham Lincoln, he is observing this way. So for reference line, it is making theta. But if we flip this coin is flipped. Abraham Lincoln is observing this way. So the ray of vision, this one, makes an angle 360 minus theta for that. So one corresponds to heads and the other corresponds to tail. So we will not consider the 2 degree of freedom. It is head and tail. This is not corresponding to a real number. So we will select this one.